All right, talking about chamber A. In the PS5, and I'm sure there's others, there's a spring. We have a spring. Spring. What does a spring do? Okay. Spring installed to open poppet, valve at idle speeds. EMF. Oh, I2. Chamber B. Chamber Bravo is
Section.
so Venturi section. Venturi suction. It is a negative pressure. Or suction. Same thing. Negative pressure or suction that tends to that I don't have to write tends to that open the poppet. And I'm going to repeat myself about the idle spring. Idle spring. Why do we need an idle spring?
So we can run it on.
Well, yep, at idle, there is insufficient, means not enough. AMF stands for, so there's not enough air metering force, so a spring is added to hold the poppet, is added to hold poppet off its seat enough to get idle fuel. So a spring is added to hold poppet off its seat enough for idle fuel. All right, also included in the air metering force is the automatic mixture control valve. Also called the AMC. I almost said AMF. The AMC, automatic mixture controlled. Put here, see, can be installed. In the line, can be installed in the line from the impact tube. Installed in the line from impact tube. So which one has it installed near the impact tube going into A? The big one. There you go. We can call them big and small. I'm fine with that. So that's the PR58. PR58. That's the big one. What do we need then if we're going to do that? Got it. This will require a bleed. An air bleed. I should say air bleed. Air bleed between what? Yep, A and B. You guys are getting it. Or between impact and Venturi section. And that's like the PS5, not the PlayStation. What's like the really cool new PlayStation? It's PS5. I don't have that, but I have children. But
do your kids have it?
No, apparently not, because when I was in Boston, my son was pointing out this brand new building, as we call it the PS5 building. I'm like, why do you call it that? He goes, because it looks like a PS5. I'm like, I don't know, a square box? And he goes, Dad, that's the old one. And he showed me one. It is. It's this huge building. It's really cool. I'm like, oh my gosh, that is a PS5. He's like, I told you. So anyway, let's see, or between impact venturi like the PS5. In this case, the AMC, the automatic mixture control, automatic mixture control restricts, let me see, restricts or opens an air bleed between A and B. The what? The needle valve, yep. So really, I'm going to regret this one. We could, if we wanted, I suppose, or not we, the person who designed it, got rid of the AMC up here, and they could have put it right here. Made the bleed little, just put a needle right there. That'd be an inverted needle. As we went up in altitude, it would expand. Yeah, it'd be an inverted needle. Inverted needle, so it would look like with the bellows here. So when we were down low and cold, it would contract, and the square part would be right here. You can't see that very well, probably. Square part would be covering that up, blocking the bleed, so A and B would not bleed at all, and it would run. Say Rich. Rich, very, very good. And then as we went up in altitude, this would expand, exposing the smaller section of the needle, which would allow air to bleed between A to B, which would cause it to go lean. This is interactive. You're allowed to say something. All right. Let's see, automatic mixture control. And then let's just say it one more time. So air metering force. AMF equals A plus B. Those two work together. All right, fuel metering force. All right, we're going to add chamber C, which is metered fuel pressure. Chamber C, metered fuel pressure. Right, it's metered because it's already been through all of the metering orifices. One is a positive pressure, but works with or against D? Against D. Is held constant. It's held constant throughout the entire range of operation by. It's held constant throughout the entire operation by the what? What component keeps it at a constant pressure?
Oh, I almost fell for it again.
Discharge needle, nozzle, whatever.
We'll call it discharge nozzle.
Discharge nozzle. Seen that look you're giving me.
Yeah, it does have the needle off to the side on the PS5. We'll just call it discharge nozzle and keep things simple. Discharge nozzle. Oh, thank you for that. I don't know what that is. What?
Or the needle before trap.
Yes. 2. Chamber. What? I want to at least see the, for For those of you that haven't been able to answer your questions so far, I figured you can go A, B, C, D and shout one out there and get one right. So yes, chamber
I'm
D.
smart.
Yes, I knew it was D. Can I have the oral now? You realize I'm not going to ask you what comes after, like B. Name the chambers in alphabetical order.
You are now signed off.
All right.
C, B, A.
Unmetered fuel pressure.
All basic.
I don't know if I ever get pulled over for a suspected DUI and they ask me to do the alphabet backwards.
Backwards, yeah.
I'm just doing that and going, well, let's go, because that ain't gonna happen. They're not gonna happen sober.
Balance on one foot. It's just balance muscle.
Maybe if you had a couple, you can do it backwards, and that's the trick. Ah, you did it. You're drunk.
Oh, it was just for fun.
Let's see. D. One is positive pressure. That tends to what the poppet? Close the poppet. I didn't do that with C. But it works against D, so chamber C tends to open the poppet. Very good. Let's see. Chamber. Okay. Chamber. Let's hear it. E. Very good for those of you just joining us here. Chamber E. All right.
Welcome to the show.
No, I shouldn't say that. They've been here all along. They're just waiting for a chance to, be sure about something. Fuel pump pressure. Fuel pump pressure. Fuel pump pressure. One, a positive pressure. A positive pressure that does not affect the poppet. And that is somewhere in the neighborhood of 9 to 14 psi's. And therefore, fuel metering force is D minus C. Very good. Unless it's like the 55 PS5 where it doesn't have a C involved, it's just a D.
Well, it still has a C.
It still has a C, but it's not really affecting the poppet.
No, but it's still.
Still there.
It's still D minus C. Because C is still constant pressure. No?
Yep. You're right.
It's just. Yeah. That's what it is.
We're referring to that one where
Where C is.
C doesn't have an effect on the poppet here.
Yeah.
Right.
But it's still a factor.
Still a factor. What?
If C were 0.
Yes, if C were 0. Okay. Okay, fuel metering force. Let's see. I feel like I'm being redundant here, but operation of air and fuel metering forces. So operation of fuel metering force and air metering force. All right. As air enters the carb, air proportional to velocity hits impact tubes. Air proportional to velocity, which is to say the faster the air is coming in, the more it hits the impact tube, the more pressure it's going to cause. Velocity hits impact tubes. Yes.
How sensitive is the air impact air pressure to air density as opposed to velocity?
I don't really know that.
Because if the combination of the impact tubes and the material suction gives you a system that can meter by air mass, something has to be
Yes. So I don't fully know the answer to that, exactly how it does it, other than it does it.
Could we say the more pressure equals more density?
You have to be careful because density has to do with temperature and altitude, so to speak. But not altitude, it's just because we can have high density here without ever leaving and we're still at low altitude. But that's what it's supposed to pick up on. But obviously it doesn't pick it up perfect, or you wouldn't have to have an automatic mixture control. Otherwise the two things working in conjunction would just satisfy the need all the way up to any altitude. So you got to have some correction. Okay, air proportional hits impact tubes. This higher pressure enters A. I'm not going to put chamber A, just a big A. And I'm going to just do something weird. I hope I don't regret this. I'm just going to put we will give this a random value of 1. 1 what? It doesn't, call it PSI if you want. It's just 1. Now, it doesn't mean that's what it is. Just something I did. I'm just going to say it's a 1. All right? Just for teaching purposes and explanation values. Okay, 2. 2. As air flows through venturi, low pressure is created. So as air flows through venturi, low pressure is created. Low pressure is created. This lower air pressure, this low pressure, or suction, enters B and tends to what? Open or close the poppet? Tends to open. A tends to open. All right. And we will give this a random value. I'm just going to put value of 0.25 because it's suction and it's not a lot. All right. So the differential pressure of A and B, so air metering force is then equal to A plus B, right?
Yes.
Okay. This force opens poppet, right?
Yes.
Okay. And our value, our made up value is
1 plus.
1.25.
Yes.
So A plus B is 1.25.
Are you waiting for somebody to say, where did you get the 1 from?
Well, since you didn't know.
Yes.
No, I think everybody was. Oh, my students. They either heard me say it, or at this point they're afraid to ask. So half of them heard me say where I got it from. The other half like, I don't know where I got it from. I'll ask later.
Yeah. I'll ask fellow student.
Okay. Point number this one. 4. Unmetered fuel. Unmetered fuel is delivered by a pump. Unmetered fuel is delivered to which chamber? Yeah, I shouldn't have called it unmetered. What's the first chamber it enters? Fuel pump pressure. So, what's that?
Chamber E, they use the term unregulated.
Yeah, that's what I should say. Unregulated. We'll call that. Unregulated fuel is delivered to E. I did want E, right? Yep. At what kind of PSI?
9 to 14.
9 to 14 PSI. Oh, okay. So one thing almost everybody always gets. Oh, it's always 9 to 14. Okay, I'm going to have to move over. So everybody got this?
Delivered to E. Yes.
Okay, it'd be V5. So air metering force, AMF, AMF, opens poppet valve. Allowing unregulated. Actually, it's not unregulated, it's regulated, right? They should call it regulated. It's regulated.
I think they make a distinction between regulated and
And it depends on which one we're looking at.
You're thinking it's regulated.
This one's going to just call it fuel inlet.
Yeah.
And
say allowing to say fuel. But
this one calls it inlet, just inlet. It should be called regulated because it's regulated off of the fuel pump, so it does have a regulated pressure to it. So, we'll call it regulated. To allow regulated, that's fuel pump pressure. Let's see, fuel, allowing regulated fuel to enter which chamber?
D.
D. Now you have to go backwards, E to D, because we're going that way. All right. Let's see. Okay. This pressure is this pressure is more or less than E. D. Is D more or less than E?
Less.
Which has the most pressure of all of them? E. Which has the next highest pressure? D. Next highest pressure. C, next highest?
A.
You got it, A, then B. So go D, Echo, Delta, Charlie, then over to A, then to B. So, this pressure is less than E because it went through the poppet. Because, I actually wrote that, because, B-C-A-U-S, because poppet acts as a restriction. Acts as a restriction. Okay, so again, we had the air metering force open the poppet, fuel went from E into D, and now the pressure in D, so this pressure is less than, and this pressure tends to close the poppet valve, tends to close poppet valve. And lastly, we've got, VI, metered fuel pressure enters chamber C. It's chamber C. All right, so metered fuel pressure is less than what? See if you read my mind. Is less than D because
C is a constant.
it is because the fuel passed through the fuel control unit because the fuel passed. The FCU fuel control unit. And pressure is regulated by the what? Discharge nozzle. This pressure is variable or constant. Constant at 5 psi.
Is that going to be our made-up number?
No, that's real.
It's actually
9 to 14 and 5, I believe, are total real numbers,
okay.
which is how I reverse engineered the other numbers. All right, remember the poppet has to be in equilibrium. If it's out of equilibrium, it moves all. It's kind of like, fine. If he's pushing on my coffee cup with 1 pound, I got to push back with another pound. If I'm not, and I do half a pound, we're just going to go off the edge of the table, which is what happened to my other coffee cup. Don't do that. So it's got to be in equilibrium. But you want it to be able to open a little bit and stop. Yeah.
I have a question.
Yes.
You said that chamber E does not affect the poppet,
Correct.
so it's not providing that equilibrium.
No.
It's just allowing fuel to
See, it's
flow.
back here. Chamber E. Doesn't have any diaphragms.
I see. So it can't really
Can't-
push the poppet.
Can't push or pull.
I
Yeah,
see.
it has some area there it can push on, but that just comes right back around. Comes right back around and pushes on this one at the same size. So
Okay. I see.
no, E has no effect.
Got it.
It's just let it in there. All right, so ooh, Elon Musk sends a warning. Okay. All right, because I wrote because the poppet wants to be in equilibrium, it needs to be. Needs to be in equilibrium. D must be at what PSI? Well, it'll be 6.25 PSI. Why must it be at 6.25 PSI?
So all the other ones I know, equals 6.
Because A had a value of 1, B had a value of 0.25. It's a suction, but it's pulling on the diaphragm the same way that A is pushing. So if A is pushing it this way, B is pulling it this way. So the two work together. So that's why it's a plus. You don't take away the suction. I hope everybody sees that, how it's working. C is at 5, and so 1 plus 2.5 plus 5 equals 6.25. And so the only thing trying to close it is, so we've got 6.25 going that way. We got to have something going this way, or the poppet continues to wander open. And that value must be 6.25, which is D. Follow? I hope. Okay. Let's see. What if we add throttle? So let's add throttle. Let's add throttle. Let's add throttle. All right. So I'm not going to write all this out, but we add some throttle. So impact air goes up or down. All right. Impact air goes up. Does what really made that impact air go up?
The throttle opening?
Yeah, so it did, but the impact tubes are out in front of the carburetor.
Oh, the speed of the plane?
That's why I was not the speed of the plane.
Ah,
Yes, I wanted to make that distinction because otherwise it wouldn't work if I had my feet on the brakes. And it's behind air filters, and it's not the speed of the airplane.
oh, the
It is
speed of the air.
the speed of the air inside of the intake chamber. That's not the word I want. What?
Manifold?
Is that from the propeller?
Manifold? Intake?
Manifold's the other side.
Okay.
So that's why I didn't want to use it. It's the air intake manifold. Man, I don't want to call it that. It's
Just air intake.
yeah, it's the air intake system, plenum chamber if you want. Right now, I will say that. So we have the air filter and then an inlet duct. That's the word, inlet duct. If I'm sitting there running the engine with my feet on the brakes and a propeller in front of it, that propeller does force air in there. That propeller has an effect, as opposed to if the propeller's here and I put the air inlet over there, I won't get that propeller effect. So you actually, it's good. You want that air inlet behind the propeller. And so we would have a certain amount of pressure sitting there. As I lift my feet off the brakes and roll down the runway and start picking up to 100, 200 miles per hour, it's going to force more air in there. So yes, the propeller and the forward velocity will increase that pressure, which then would increase it on the impact tube, but most of it's going to come from the engine sucking the air in, because it has to be able to work when you're not going forward. But going forward and the propeller add to it. So impact air goes up. Let's see, impact air. Let's add 0.25. So went up a little more. So now how much is my pressure in A? So A equals 1.25. You guys see where I got that from? It's a made up number. I made it up. So 1.25. Because before it was 1, now we added some throttle, so A has to increase, so it's 1.25. Let me see, so impact air goes up. What about the Venturi suction? I call it Venturi suction, not pressure, so we're all kind of, yeah. So Venturi suction goes up, and let me see. What do I call it? Venturi velocity. Okay, another 0.25. So we'll go B equals now 0.5. Okay, so B is 0.5. So C does what? Okay, constant. So that's going to equal 5. So just stays constant. So what is my air metering force proper, AMF?
6.75?
Now look up air metering force. Air metering force is only two things, A and B. 1.75. But fuel metering force is D minus C, but look a little bit different. C, is that closing or opening the poppet? C is trying to open, so we can add that. So my opening force is, well, AMF, air metering force, plus C. Everybody follow that one? And so AMF happens to be 1.75 and C happens to be 5. So my total opening force equals 6.75. And that's going to do what to the poppet? Right, so now the poppet opens a little. Poppet opens. Poppet opens. And so regulated from E now flows into D until D becomes, so opens until D gets to 6.75, and then it stops. So it's back in balance. All right. Or we could close the throttle, right? Close it back the other. Well, I'm not going to do it all, but close the throttle. A goes down, B goes down, C stays the same. So since those two went down and D is now greater, it pushes back. And it's going to start pushing back until that pressure coming from E to D equalizes with A and B again. So now it's closed. And so less fuel is flowing, which is good because we have less air going. So there we go. Let's see. I have chamber review, which I think we're good at. Let me see. We'll see. I have chamber. Chamber review. Chamber A does what? Impact air, which tends to open the poppet. Hey, by the way, on your test on Friday, I'm giving you these drawings. They're just unlabeled. So you'll have both drawings right in front of you. You don't have to memorize what these carburetors look like. You don't have to memorize chamber A is. You need to look at the drawing. If you can look at the drawing and just go, oh, there's the impact tube. It goes to that. I'll call that one A. That's impact. So that's all you have to do.
Is it, so that's filling, you say? Or is that?
No, but you're going to get the drawing without labels.
Got it.
So
know the chambers and nomenclature, or just the chambers?
Never given you the answers to the test.
What's that?
Someone has ever given you the answers to
Yeah.
the test.
Just saying you don't have to memorize what it looks like.
Give us
Appreciate
all the answers for 4 days before the test.
Let's see. What's that?
He said you give us all the answers 4 days before the test.
That's right. Starting 4 days before the test. I'm giving you all the answers right now. and have been for the last 2 days. So just write down everything and memorize it.
Yes.
Okay, chamber A is what now?
Impact.
Impact, and it tends to?
Open.
All right, chamber B is?
Series.
And it tends to? Open. What would happen if we had a hole in the diaphragm between A and B? If we had a little tiny pinhole between A and B, what happens? Well, they'll try to, but if it's a little tiny pinhole, they're not. You can have a little tiny bleed. So what's the carburetor going to tend to do? Go lean, because air metering force decreased when it shouldn't have. If your carburetor's running rich, open it up, poke a little hole in A and B. Put it back together, you'll be fine. Or adjust the mixture, whichever makes you happy.
The service fault for that.
Let's see.
Calibrated.
All right, chamber D receives unmetered but regulated fuel pressure and tends to close the poppet valve. Chamber C and D work against or with each other? Against. All right. If diaphragm between C and D ruptured, what would happen? I mean, that's a full blowout.
It's gonna just force that thing.
You're gonna flood the engine.
We had a complete blowout here. So you want to flood the engine?
You wouldn't get constant pressure, so you wouldn't let it stop, right?
We'd have no force
You wouldn't have enough
to
fuel.
close, so you wouldn't run rich.
Well, which way would the poppet valve go? Let's try that.
Close it.
It would open.
We've lost D and we've lost C.
Oh, we've lost, oh,
Yeah, we've ruptured this. So if you ruptured it, a big hole here, nothing's pressing either way.
full of.
So which
You get free flow to
Really
the
rich.
So the right fuel pressure.
A and B wins, it's going wide open, and it's going all kinds of haywire. I may just bypass and go down this way. What's that?
A and B are go faster.
A and B are going to push it wide open.
Yeah.
Yeah, there's still.
So yeah, it's going to go wide open, and the only spot you're going to find that this thing may run is where?
Full throttle.
What if we had a total blowout of A and B?
No fuel.
Starvation.
Work it idle.
It would what?
Work it idle.
Work it idle.
Let's go, Brandy.
Because what's the idle spring there for? Idle spring's there when A and B don't work. So if A and B don't work, idle spring does. So, let's see.
Process
When you put that spring, is it just in chamber A?
One, it's on chamber A. This one, look at the picture. Where is it? It's a thing called idle spring.
Oh, D.
D.
Got it.
Doesn't matter if it's an A or B. It does the same thing. Let's see. Parts of the crush valve. The throttle unit. Oh, I guess I could write this stuff down.
What did you say ADI was again? ADI system?
Anti-detonation injection. I will get to that for sure. All right, main parts of a pressure carb system. Main parts of pressure carb. A, we have the throttle unit. Throttle unit. Let's see, controls and measures the mass airflow of the engine. Airflow is measured by volume and by weight. So I'll write all that. Controls and measures. Controls and measures the mass airflow mass airflow to the engine. Airflow is measured by volume and by weight. It contains You should know this. What does it contain that does the measuring?
Venturi?
Okay, venturi and
Impact tubes.
impact tubes. Impact tubes and venturi. Or venturis. Impact tubes, because there's many of them, and venturi, possibly pearl, because many pressure carbs have multiple venturis and even smaller boost venturis. And the throttle valve. We have the regulator unit. So one automatically regulates fuel pressure to metering elements in the fuel control unit. So automatically regulates fuel pressure. Fuel pressure to metering elements. In the FCU, regulates the fuel pressure of the fuel going to the FCU is another way of saying that. It contains, what does it contain?
Orifices.
Chambers A, B, C, D, and E. I feel like it's a Dr. Seuss book. Little chambers A, B, C, D, and E. How many diaphragms are in there?
4, 5.
2. Correct. 2 diaphragms and the poppet valve. All right, so that's the regulator unit. Right there, regulator unit, this part right here, A, B, C, D. It's not really labeled regulator unit, but there you go. I think it was in the previous one. The first one we looked at. That one. There we go, regulator unit. A, B, C, D, and we have E on ours. And now we're moving up to the fuel control unit. A, B, C. Fuel control unit. FCU receives fuel under varying pressure from the regulator. Receives fuel under varying pressure from the regulator and meters it to the discharge nozzle. Meters it to discharge nozzle. It contains 1 or more metering jets. And it contains metering valves. Like the idle needle valve. Remember that? No, at least he's honest.
Yeah.
Everybody else is like,
Idle, oh, there we go. This thing,
Yes.
oh, step down.
Still right.
the step nozzle.
Step.
And the discharge nozzle. Which injects fuel into the airstream. Into airstream. It may mix air from A or B.
Hey,
Yeah, I know my notes say B. I'm like, nope. From A to emulsify. It opens at a preset pressure. How come we don't want to open it early? Why don't we, if it opens at 5, why not open at 2 or 3?
So no, run rich.
Nope. Nice try. So why are we not, the question is, why don't we want just a little bit of fuel instead of the right amount? If we put just a little bit of fuel in, it won't run rich. It would run, it would run super lean, and it would like diesel on, and it's not designed to run there. So we want it to run where it's designed to run. So wait till everything builds up to 5, now open it and start spraying it. 2, what do I got here for 2?
One opens at a,
Preset.
oh, preset.
Preset value. Yeah, I missed a vowel there. Let's see. Also, keeps downstream pressure constant. And what is that constant pressure? 5-time constants.
Would that be upstream pressure?
Yeah, it would. Stupid book I copied it from. I should have put 0.3 right here, but I'll put it right here. 0.3 was, it is a form of a pressure relief valve. That kind of really goes right there. Pressure relief valve. And last point, usually has a shut-off valve spring. So has a shut-off valve spring. And it keeps fuel from dribbling into engine at cutoff. It keeps fuel from dribbling into engine at idle cutoff. When you want it shut off, you want it shut off right now. And that's vented to B. Vented to B for assist. It's not even time. Those guys are getting out early, so calm down. All right.
You gotta go, man.